we did a genetic trick that allowed us to decrease the methylation. I will have to say right away that in humans, both of the drugs are toxic and the genetic tricks cannot be done. But mice, which are genetic Olympic superstars, are able to do the genetic trick and tolerate one of the drugs known as trichostatin A or TSA much more readily than do people. The other drug, unfortunately, is toxic in mice as well. So what Joly was able to do was to give the drug to mice that were genetically equivalent, were genetic mimics of ataxia-telangiectasia. And what he saw was that using either the genetic tricks to decrease the methylation or the drug to increase acetylation, in both cases, the cells of the brain began to behave properly. So they stopped showing signs of degeneration. They started looking better in terms of their structure. And empowered by all of this, Joly then went and gave the drugs and the genetic tricks to live mice and asked, can we improve the behavior of these animals? And what he was able to show, much to our delight, was that, in fact, it worked. So the mice able to tolerate the trichostatin A went from being a little bit clumsy on a rotating rod known as a rotorod to being able to sustain their balance on that rod for much longer. They didn't quite make it to normal, but they did a lot better than their untreated brothers and sisters. The same thing happened when he did the genetic tricks to decrease the methylation. The mice were able to stay on that rotating rod, not as good as their wild type or normal brothers and sisters, but they were much better than the animals who had been untreated and carried the ATM gene. And now I have to say, so now you're right at the cutting edge of where my lab is. And we're very excited. And every day, I allow myself exactly 10 seconds of ecstasy because these results are really exciting. And one of the things that I think is most exciting about them is that relates to the animal experiments. So what Joly was able to do was to take animals that had already begun to demonstrate behavioral problems, and by giving them the drug, back up the problems. And this has, I think, hopeful implications for treatment in humans, because it suggests that at any one moment, all of the deficits that are present in an individual with the disease are not permanent. Some of them can be backed up. But now, I'm sorry, but your 10 seconds and mine of ecstasy are over. I would remind you right away that the treated animals did not get as good as their wild type or genetically normal brothers and sisters, but they did get better. And I would also remind you that what Joly and I were able to do was to fix mice. And now it's time to roll up our sleeves and do the really hard work of taking that bit of laboratory science and translating it into an AT clinic where it can make a difference in people's lives. So how are we going to do that? Well, for one thing, there's more basic science that we need to do. First, it's my profound hope that other researchers and other laboratories can repeat our findings. Repetition is the gold standard of science, and I'm not immune from it. It has to be replicable in other labs. I said that the 2 drugs that we used and the genetic tricks are not really usable in humans. So we need to look for old drugs that are usable in humans that might subserve some of the same functions and begin to test these as quickly as we can in people. Part of my job right now is also to look for new drugs that speak directly to the problems that we've seen in the cells that we've studied. So, for example, this HDAC inhibitor that we used, the trichostatin A or TSA that we used, the drug that was tolerated by the mice, that's getting at the problem that Jali identified in an indirect way. And the problem is that ATM acts in a very complicated way to reduce histone deacetylase activity. It actually doesn't interfere with the enzyme activity. It interferes with where in the cell the enzyme is. So one of the things we hope to do is find a drug that prevents the shift in cell location. This would be a new drug. No one's ever looked for this before, but we need to go do that. We need to go look for drugs that'll alter the histone methylation so that the coat can be kept loose. And then these drugs need to be handed off to the clinicians to be taken into the clinic and tried first for safety and then for efficacy. And unfortunately, we don't escape the slide that Dr. Gaddy showed you. In other words, that the gulf between the laboratory and the clinic is large and difficult. But I still allow myself 10 seconds a day. And I think I'm a cautious person by nature. I feel in many ways the biomedical community has overhyped so much of what they've done and made promises they can't keep. But I'm going to allow you all 10 seconds a day, but no more. I think what we have is maybe established here is just a novel approach, a different way. And in the end, I think my colleagues and I would suppose that there probably won't be one treatment that is going to do it. It's going to be a collection of many different treatments, and perhaps we've got our fingers on one. Anyways, it's been very exciting to be here, very exciting to be a part of this program. I salute all of you for the dedication, not just to the research, but to your families and to the cause. So I thank you for your attention.